Hi, this is Roshan. So today I'm going to teach lipid storage disorders. Welcome to Cornea. Okay. So this will be your part 1 video. In this video module, we are going to learn about the basic lipids. Okay. From the I have extracted this from chemistry of lipids chapter because this part, if you see lipid storage disorders, they will only ask for MCQ purposes. They will not take 5-mark question or 6-mark question or any that is reasoning or they will not ask it for 15-mark essay question. Only MCQs they will focus. So you can think 1 mark I can leave and go, but it is very important for diagnosing because they can take more and more MCQs, and also this is important topic for your NEET PG examination. So we have to look into it. So first of all, before that we have to understand the basics. So I have taken some important stuffs. So first understand this, then we'll go on to what are the disorders, what is Niemann-Pick disease, what is Gaucher disease, what is the Krabbe-Dystrophy, all such stuffs. Okay, yes. Okay, so let us start with the first one. Okay, so what are sphingolipids basically? Sphingolipids are nothing but sphingosine containing lipids. Okay, so what are sphingolipids? Sphingolipids are nothing but the sphingosine containing lipids. Okay, so now I'm going to classify the sphingolipids. The sphingolipids is classified into 3 types. One is phosphosphingosides, then the next one will be the glycosphingolipids, and the next one will be the sulfatides. So let us write that. Okay, phosphosphingosides, glycosphingolipids, and the sulfatides. So under the phosphosphingosides we will be talking about the sphingomyelin, okay, which is a very important constituent of your CNS. Yes or no? Yes. So before going to all such stuffs, let me discuss about some important stuffs. So this is nothing but sphingosine. Okay, this sphingosine is a part of the sphingomyelin. Okay, it's a very important constituent of the sphingomyelin. Okay, so okay, now let us discuss what is a ceramide. Okay, see they now only we have discussed about the sphingomyelin. This part this part is nothing but the sphingosine. மேலே இருக்கு பாருங்க, கீழே இருக்குல்ல இந்த C double bond O bond R, this is the fatty acid. So can I call a ceramide as sphingosine plus fatty acid? So when a fatty acid is attached to sphingosine, can I call it as a ceramide? Yes or no? Yeah. Next. So the next one is a sphingomyelin. In sphingomyelin, what are the stuffs you can find? Can I say there is a sphingosine group? Yes or no? Can I say there is a fatty acid group? Together, what you will call it? Sphingosine, and this one, can I call it as a ceramide? Yes or no? Then what I have got here is a choline group. Did I get a choline group here? In the center, there is some important stuff, or there is something which is there which you would have not noticed it in the ceramide. Yes or no? So this is nothing but your phosphoric acid. Yes or no? So in the sphingomyelin, you can find that there is a phosphoric acid. But in the case of a ceramide is nothing but it's a variety of glycosphingolipids, which we will be discussing. Okay, so here we are discussing about the classification of sphingolipids, under which we have the phosphosphingosides, glycosphingolipids, and the sulfatides. If you just see the phosphosphingosides, that is only that sphingomyelin, which you can find it here, that it has got a phosphoric acid group. But in the case of a ceramide, which is a glycophospholipid, it does not contain a. This is the main difference which I want you people to analyze very carefully. What is that? So here there is no phosphoric acid moiety. Yes or no? So this is what I want you to notice. Okay, is it clear? So what are the classification? Once again, let's revise the classification. Sphingolipids, it is classified into phosphosphingolipids, glycosphingolipids, and the sulfatides, under which we have discussed some important stuffs. Okay, let me go it very faster so that we can finish it on time. Okay, so first of all, the phosphosphingosides. Let us discuss about the phosphosphingosides. Okay, Siri, Nama, what is the today's topic which we are discussing? Lipid storage disorders. First of all, I didn't discuss one stuff. What are lipid storage disorders? See, there is something. All these phosphosphingosides, phosphosphingolipids, and phosphosphingosides, glycospingolipids, sulfatides. All these are nothing but the lipids only. No, if these lipids accumulate in the lysosomes, okay, so if these lipids accumulate in the lysosomes, it may what is the function of lysosome? What is the function of lysosome? Comment it in the comment box, you comment it. Okay, so it is nothing but the autolysis. It will cause the fusion of phagosome and the phagosome lysosome complex. All such stuffs will take place. No, so all these digestion will be broken, will be stopped if more and more lipids accumulate. Purida. So more and more lipids, once if it accumulates na, their excretion process நடக்காது செல்லுக்குள்ள. So அந்த செல் வந்து என்ன ஆகும், இறந்துரும். Correct or not? So that is what is going to happen there. So that's why these diseases are very dangerous. So that's why we are studying this group of diseases, and these are clinically very important. Okay, here what biochemistry we are studying in this medical field is medical biochemistry. So you should know more and more clinical stuffs here. So most commonly, where are these phosphosphingosides present? They are mostly present only in the biomembranes. That is, especially these they are present in the central nervous system. Okay, so they are found in abundant. I'm sorry. Yeah, they are found in abundant. Okay, so they are most commonly present in the biomembranes, especially in the nervous system. Yes, so that is what we call it as sphingomyelin. Okay, what do we call it as? Sphingomyelin. So in sphingomyelin we have discussed that there is one sphingosine group. I can remember that there was one sphingosine group attached to a fatty acid group, and there was a phosphoric acid group to which the choline group is attached. So that is what here, phosphoric acid present but no sugar moiety is seen. What do you mean by sugar moiety? Whenever you see the word glyco, that means there is something, sugar moiety is present. Yes or no? Here you can see that here you can see that glyco word is present or not. So glyco word is present or not. So I can confirm that the sugar moiety is present or not. So sugar moiety is there. But okay, so the easy way to say this, okay, only in phosphosphingosides the sugar moiety is absent. Okay, sugar moiety is not present in the phosphosphingosides. Okay, only in the case of phosphosphingosides. Okay, sugar moiety is not present. Okay, next. So if you just see the sphingomyelin is amphipathic in nature. What do you mean by amphipathic nature? See, amphipathic means dual role. It is going to act as both emulsifying agent as well as the detergent. Okay, one more stuff which I want to say about the amphipathic nature is the surfactant importance. Let me discuss. Yes, you can answer this question. I'll just write it as one question. Sphingosine plus fatty group is, what is it called as? Ceramide. Okay, is it clear? Sphingosine plus fatty group is nothing but the ceramide. Okay, so now let me discuss about one more stuff, that is lecithin and sphingomyelin ratio. Okay, Siri, what is lecithin sphingomyelin ratio? Okay, yes, sphingosine, if you just see, it is very very important in fluids like bile fluids. Sphingosine is an important constituent of bile fluids, amniotic fluid, all such stuffs. This sphingosine is a very important constituent. Why is it very important? Because if you just see, we can detect the fetal lung maturity with the help of the ratio in our amniotic fluid of a woman or bile fluids. If you just see, the lecithin and sphingomyelin ratio should be maintained. Okay, if not, it might so with this we can detect the fetal lung maturity. Let's see how. So now let us talk about the lecithin sphingomyelin ratio. If the lecithin sphingomyelin ratio is less than 2, then we can say that the fetal lungs may be deficient. Okay, so that's what I'm going to write here. So if it is less than 2:1, then the fetal lung may be deficient. fetal lung surfactant may be deficient. I didn't mention the word surfactant here. Okay, if the surfactant is deficient means what will happen to the lung? The lung will collapse. Okay, is it clear? Yes. So this is what I want you guys to learn about the sphingomyelin. One more stuff I want you to say. ஸ்பிங்கோமைலின் ஓவர் அக்யூமுலேட் ஆகிட்டே இருக்கக்கூடாது. அதாவது ஒரு செல்லுக்குள்ள ஒரு லிப்பிட் அக்யூமுலேட் ஆகிட்டே இருந்ததுன்னா அது லைசோசோமோட ஃபங்க்ஷன்ஸ் எல்லாத்தையும் டிஸ்டர்ப் பண்ணுன்றது நம்ம படித்தோம். சரி, இப்போ ஒருவேளை இந்த ஸ்பிங்கோமைலின் வந்து உடனே வந்து டீக்ரேட் ஆகணும்னா ஏதாச்சும் ஒரு என்சைம் அந்த வேலையை பார்க்கணும்ல. எந்த என்சைம் அது? That is very simple. You can itself think of it. That is called as sphingomyelinase. Yes or no? The enzyme will be sphingomyelinase. Correct or not? So if the sphingomyelinase is there, if the sphingomyelinase is there means then it will be helping the sphingomyelin to degrade, okay, to do its function and to degrade. That's all. But if it accumulates more and more, then there can be one cause. This sphingomyelinase can, if it is deficient means the sphingomyelin can accumulate or not. Sphingomyelin degrade ஆகணும்னா தான் sphingomyelinase இருக்கு. இப்போ sphingomyelinase is absent means what will happen? The sphingomyelin will accumulate in the lysosomes, which leads to a disease called as Niemann-Pick disease, which they will compulsorily ask in MCQ. Okay, is it clear? Clinical features will be dealt in the part 2 video. I'll tell what to study in part 2. Is it clear? Are you thorough about the sphingolipids? Okay, so that is, we have discussed about the sphingolipids, phosphosphingosides we have covered. Now I am going to talk about the glycosphingolipids. Okay, so let us talk about the glycosphingolipids. What are glycosphingolipids? Glyco means itself, I can say that, you can say that there is sugar moiety is present. So they're widely seen in the nervous tissue and they do not contain phosphoric acid. So this point I can highlight because we have discussed it already. So they do not contain the phosphoric acid. Yes or no? Yeah. But they contain what? Glycosphingolipids contain ceramide and what? Ceramide and a carbohydrate. Okay? Yes or no? Okay. Now, if you just see, we can classify this glycosphingolipids into 3 types. One is going to be the cerebrosides, the next one is globocytes, the next one is the gangliosides. So let us discuss it one by one and the diseases associated with it. Okay, so ceramide plus carbohydrate. So if the ceramide, let us consider if there is ceramide plus, if the ceramide acts with glucose, then what will you call this lipid as? Glucocerebrosides. If the ceramide is present on a carbohydrate sugar like galactose, then can I call it as galactocerebroside? Is it easy? Is it easy or not? Yes or no? Yes. So there is some enzyme which will help this glucocerebroside to degrade. That is nothing but the enzyme name is beta glucosidase. Okay, the enzyme name is beta glucosidase. Is it clear? So this enzyme will help the glucocerebroside to degrade, and the galactocerebroside is degraded by beta galactosidase. Is it clear? If this enzyme is absent, what will happen? So can I say there can be a disease called Gaucher's disease? Yes, if beta glucosidase is absent, then due to a glucocerebroside, so there will be a disease which occurs that is called as the Gaucher's disease. Okay, is it clear? And if beta galactosidase nala vanduchna, the disease is nothing but Krabbe's leukodystrophy. All the lysosomal storage disorders are primarily going to cause the mental retardation. So for biochemistry, you don't have to learn all the clinical features. I just want you to learn the lipid accumulating and the defective enzyme. Is it clear? Okay, so now let me talk about the globocytes. Globocytes are nothing but, if you just see, they contain two or more sphingosine, that is hexosamine molecules. That is what, we can take here. I'm showing you the sphingosine. Okay, so two or more hexosamine molecules, they are attached to a ceramide molecule. Okay, so what is a ceramide? What is a ceramide? Define a ceramide. Ceramide is nothing but the combination of a sphingosine plus fatty acid. Yes or no? So two or more if you just see, two or more hexose molecules, okay, hexose or hexosamine molecules attached to a ceramide. Okay, so two or more hexose or hexosamine molecules, if they are attached to a ceramide molecule, then we call it as a globoside. Okay, then what is ceramide oligosaccharide? There are two distinct terms, that is, one is globoside and ceramide oligosaccharide. Both are 99 percentage, that is 99% same they have mentioned, but just I want you to remember this stuff. Ceramide oligosaccharide is nothing but, it is a ceramide plus oligo means 1 to that is up to 2 to 10 you have studied. So oligosaccharide here is nothing but so before we have discussed ceramide plus glucose, ceramide plus galactose. Now I am going to write ceramide plus glucose plus galactose. So I can also call this as the globoside. Okay, so that is what, hexose or hexosamine molecules. Okay, is it clear? So that's what, ceramide plus glucose or glucose plus galactose. Okay, this is nothing but the ceramide oligosaccharide. Okay, so this is ceramide plus glucose plus galactose. This ceramide plus glucose plus galactose is collectively called as lactosyl. Why lactosyl? Glucose plus galactose is nothing but the lactose only, right? So lactosyl ceramide. Okay, I'll write in another color so that you can differentiate. Okay, lactosyl ceramide. Okay, is it clear? So ceramide plus glucose plus galactose, so this is collectively called as lactosyl ceramide. Okay, is it clear? Okay, so this is all about the globoside. Okay, so now let us discuss about the ganglioside. What is ganglioside? So if you just see ceramide, when a ceramide oligosaccharide have one molecule of nana attached to them, that is nothing but glucose, galactose, ceramide, that is the ceramide, glucose, galactose, and attached to one molecule of nana. This is nothing but your sialic acid. It is nothing but N-acetyl uramic acid. Uramic acid we will call it as. Okay, so when it is attached like one molecule is attached with this ceramide, glucose and galactose, that is the ceramide oligosaccharide, then we call it as a ganglioside. Okay, so you don't have to remember everything about ganglioside. So gangliosides contribute to the stability of paranodal junctions and ion channel clusters in myelinated nerve fibers. What does this statement mean? So paranodal junctions are nothing but the junction between the giant cell and you remember giant cell and one myelinated axon. Okay, so you don't have to remember this much stuff. Okay, antibodies to ganglioside 1, that is GM1, you don't have to remember all such stuffs. Just remember what is the ganglioside. You are dealing with medical biochemistry, so you just remember what stuff it is there. Okay, so this we call it as GM3 ganglioside. Okay, so this we call it as GM3 ganglioside. Okay, so on what basis I am calling that it is a GM3 means I have 2 sugar moieties attached. If 3 is attached means I will call it as GM2. If 4 molecules is attached means I will call it as GM1. Okay, so I have discussed about it. Then you have the sulfolipids or sulfatides. Okay, so sulfolipids or sulfatides are nothing but when this ceramide oligosaccharide, if I replace this nana with the sulfate group, then it is nothing but the ceramide that is sulfatides. Okay, nothing but the sulfolipids. That's what, ceramide oligosaccharide plus the sulfate group. Okay, simple. So that's what I have also mentioned. Okay, they are important constituents of the nervous tissue. Write everything, for everything you write this statement. Failure of degradation results in accumulation of these complexes, which are collectively called as the lipid storage diseases, which we will be discussing it in the further subsequent classes. Okay, so this is all about today's class. So I'm missing few points in this video module, that is what is the disease associated with the globocyte, what is the disease associated with the ganglioside. I want you to remember only some particular stuffs. Tomorrow, before coming to the next next class on part 2 video, I want you to thoroughly memorize the lipid storage diseases, the enzyme defect and the lipid accumulating, so that I can make you understand the clinical features for the medical purposes, not for your exam purpose. Exam purpose, if you read this, what is the enzyme defect and what is the lipid accumulating, that is more sufficient. Okay, so tomorrow I am going to continue this on the part 2 video module. Before that, let me discuss this for 1 minute, what is very important, what is not very important. Gaucher's disease, beta glucosidase, we discussed this. Niemann-Pick disease, sphingomyelinase, we discussed this. Krabbe's leukodystrophy, beta galactosidase, galactocerebroside, we discussed this. Other stuffs, if you just see ganglioside, we discussed GM1, GM3 only I have said. GM1 means there are 4, I have told that there is 4 molecules of sugar, and GM2 means 3 molecules of sugar, not much you can remember. So this ganglioside, okay, so this GM1 is involved means, then if GM1 is going to be accumulating means, then it is going to cause there will be a deficiency. We can say that there is a deficiency of beta galactosidase, because 4 sugars means there may be more amount of galactose, so I can say beta galactosidase. Next you see Tay-Sachs disease, ganglioside GM2 hexoaminidase A. See, we have discussed the definition of a ganglioside. What is the definition of a ganglioside? I have discussed. See here, where is that, where I discussed? See, yeah, what is the definition of a ganglioside? Ceramide oligosaccharide having 1 molecule of nana attached to them. Yes or no? So here, so it's a ceramide oligosaccharide. Basically, a ceramide oligosaccharide may contain, so in GM2 there may be more amount of the hexosamine sugars, so that's why in order to break that, the hexosaminidase A will be present, but here this hexosaminidase A is going to be absent, and this GM2 will be accumulated, and it is going to cause a very severe disease, that is a Tay-Sachs disease. Then we have discussed about this lactosyl ceramide, and when this is absent, this is going to accumulate, then it is going to cause this disease. Lactose is nothing but a combination of glucose and galactose, so beta galactosidase is involved. Okay, Sandoff's disease, globoside definition, if you just see exo sugar only, it is primarily describing, so that's what hexosaminidase A and B is involved, remember like that. Okay, Fabry's disease will be new, I will be discussing it in tomorrow's class. That is alpha galactosidase, ceramide. I will not discuss everything, I'll just tell you some important points and whatever is going to ask, and one question I'll be discussing, I'll just show you. And metachromatic leukodystrophy, it is nothing but the enzyme defect is sulfatide sulfatase. Okay, so the lipid accumulating will be sulfogalactocerebroside. So that is what here which we are discussing. Okay, so in tomorrow's class I'll show you what I'm going to discuss. Yeah. In tomorrow's class, I want you to answer this particular stuff. Okay, so today you will be able to say that for Niemann-Pick disease, what is the enzyme defective? Always we are solving the question at the end of the class, right? Sphingomyelinase, yes or no? Okay, correct. So the, oh my god. Then what is the lipid accumulating here? Cerebroside. Am I correct or not? No, it's sphingomyelin. You are saying correct? Sphingomyelin. For others, you try to fill once completion. In the next class, we'll discuss the remaining stuffs. Thank you.